So today we're here to talk about practical applications of ICH Q14 guidelines to execute digital method development. I'm just going to turn the camera off so that you guys can see the full screen. Okay, so what are we going to cover today? What is ICH Q14? What is AutoChrom? And then how AutoChrom can actually help enable ICH Q14, where you can find more information, and then we'll have a Q&A session. So what is ICH Q14? This guideline describes science and risk-based approaches for developing and maintaining analytical procedures suitable for the evaluation of the quality of drug substances and drug products. They also mention that it can be applied to other analytical procedures. So two pieces to mention here. It is a guideline. There are not strict requirements. And it's also complementary to other guidelines like ICH Q2, which is for validation. And it uses some approaches and principles and tools that are referenced in other guidelines between ICH, I think, Q8 and Q12. The final version of ICH Q14 was adopted this past November, and it will come into effect this June. So what falls into analytical procedure development? This is an image from ICH Q14, and the guideline states that it's for analytical procedure development. So that would focus on this region here. However, aspects of the approaches in the document incorporate elements from outside this region, such as ATP, technology selection, knowledge, and validation, since they are inputs or outputs from analytical procedure development. So we'll also talk about the areas outside of this orange box. In looking at analytical procedure development, ACDLabs has a product for chromatography method development. As I'm talking about the guidelines, everything I will be saying will be in relation to chromatography. Now I need to give you a brief overview of the workflow in AutoChrom before we can jump into how this relates to the guidelines. So AutoChrom is method development software. It is based on QBD principles and is data-driven, leading to a robust method and fewer injections. So the software will help you determine a better starting point by helping you with screening a library of methods for related compounds, also using predictions and experimental data to select the initial method. It uses a wizard to define a strategic approach for your method development, so you're not using trial and error. You can execute that strategy with optional instrument control. When the data is collected, it will process and track your peaks automatically. Once you've screened and optimized a method through your strategy, you can carry out robustness through simulation, which would reduce costs and the environmental impact. Finally, you can create a report capturing the systematic approach that was used during the method development project, and this will also inform development of future methods by updating a database. So the following is what the guidelines, ICH Q14, suggest to include. So for the minimal approach, identifying the attributes of the product which needs to be tested, selecting appropriate technology and related instruments or suitable apparatus, conducting studies to evaluate performance characteristics such as specificity, accuracy, and precision over the reportable range, including the calibration model, lower and or higher range limits, and robustness, as well as documenting the analytical procedure, including the analytical procedure control strategy. So if you choose to go down the route of the enhanced approach, which is not required, it can give better certainty of procedure performance, can serve as a foundation for the analytical procedure control strategy, and the additional development data and knowledge can improve efficiency in regulatory post-approval changes. So if you decide to go down the enhanced route, let's cover what that should include. So conducting risk assessment and evaluating prior knowledge to identify the analytical procedure parameters that can impact performance of the procedure. Conducting uni or multivariate experiments and or modeling to explore ranges and interactions between identified analytical procedure parameters. and defining an analytical procedure control strategy, including set points and/or ranges for relevant analytical procedure parameters. These could include proven acceptable ranges for analytical procedures, or PARs, and/or method operable design regions, MODRs. Now, when you read through these, you're probably wondering, how can software help me with this? Well, frankly, software is not the sole answer in every single one of these. In some cases, you will need other systems like your QRMs or your SOPs, test methods, but we'll go through the ways that software can actually help with this. So we're going to go back to this graphic quite frequently, but we'll go through these point by point, the different approaches that we just went through. So the first is identifying the attributes of the product which needs to be tested. Attributes requiring testing are defined in the control strategy. They inform the ATP and are informed by the product and process understanding. So what kind of tools are available to give product understanding so that we can determine which attributes to test? Today, we're focusing on applications of ICH Q14 in HPLC, UPLC methods. Many attributes of the product would not be identified or assessed by HPLC, like uniformity, water content, dissolution, but there is software that can help with things like identity and purity, as well as phys-chem properties. So the software can help you by searching libraries to help in identification. You can perform fragment analysis if you've acquired MS data. Once you've identified the product that needs to be tested, we need to think about chemistry. So our background is chemical structure drawing, and everything in the software can be linked to the structure. So let's talk about what phys-chem properties there are of your structures. So it could be one or many structures. So you can calculate your log P, log D, pKa. You can determine where there's the most overlap to help you select the best pH for separation and in turn the most appropriate column. Something like toxicity could also be useful in determining how pure your product needs to be, and that's something that's part of a platform that we call Percepta. So the next parameter that we're going to look at is selecting appropriate technology and related instruments or suitable apparatus. So this fits into the technology section, which leads to risk assessment in analytical procedure development. So in chromatography, the technology could refer to software to help. It could refer to the column, the instrument, so maybe HPLC or UPLC or something else. We're already talking about the software, so let's talk about some of the others. So what type of column should I use? What is the largest variety of columns that I can use to make sure I'm not missing something and really have the best separation? Are there compounds that would work better for me because of my compound class? So all of these questions can be answered in the column selection tool that comes with AutoChrom. So here you can see filtering of compounds by categories. In terms of variety, if you had, say, 4 column positions that you're looking at for screening, you can set that parameter to 4, and the software will display the 4 most different columns. It also groups the columns into those that are similar, which helps you to find a potential replacement column if you were maybe selecting a column based off of an old method and it's no longer available. Now, technology could also, like we said, refer to the instrument itself. So HPLC or UPLC, maybe you have a method that already worked for a similar compound, but it was developed on HPLC and you want a shorter method. So there's something that we call the method transfer tool, and that can help with this. So it will transform your HPLC method into a UPLC method. And if you actually wanted to try this out today, there is a free version on our website that you can test out. So the next item is conducting studies to evaluate performance characteristics such as specificity, accuracy, and precision over the reportable range, including the calibration model, lower and or higher range limits, and robustness. So this falls under risk assessment as well as validation. So specificity, accuracy, and calibration are generally performed as part of validation, but the guideline does mention that this can be performed prior to validation, and if so, it does not need to be repeated. Validation is outside the scope of AutoChrom, but if you would like to add those experiments to the sequence list, maybe in a pre-validation, you can. The software just doesn't generate it automatically. We also have software that can help you with generation of calibration curve if you wanted. Now, let's focus on the robustness aspect of this. So the guideline defines robustness of an analytical procedure as a measure of its capacity to remain unaffected by small but deliberate variations in method parameters, which provide an indication that it's reliable during normal use. So there are two elements in the software that can help with this one more manual and one that's a little bit more automated. So the first is our Vary Method Parameters tool. So it gives the user control to define the space that they're interested in. So you set up the parameters that you want to change and how. Now this was developed mostly for method transfer between labs or different instruments, but it could see some use in robustness-like studies as well. Now, the system will generate all combinations from the parameters that you specified and simulate what the chromatography looks like. If you want to, you can perform overlays, you can compare tables, look for things like K prime, minimal resolution, and this will be all tabulated in one place so that you can see if there is going to be a great variation. Now, if you've heard of our software previously, this is newer functionality, so it likely wasn't there previously, and this was developed with one of our top pharmaceutical companies. The second element, if you'd rather generate and run the experiments using statistics, as the guideline references, AutoChrom has capabilities to help with that too. You can see here, we can add the robustness wave to the software to help mitigate risk by varying several parameters. The system will automatically select the best design type. So looking between full, fractional factorial, or Plackett-Berman designs within AutoChrom, or we can also read in results from JMP statistical software. And if you have JMP installed on the machine, AutoChrom will automatically recognize this and use it by default. The list of experiments will be generated and the results will be shown within AutoChrom and in generated reports. Now, one other thing to note is you can always add additional experiments at any stage in any wave in AutoChrom if you want to do further analysis, something that maybe the software didn't suggest. So the next item is documenting the analytical procedure, including the analytical procedure control strategy. So this falls into definition of the analytical procedure control strategy. So in general, documentation of the procedure should be covered by your SOPs and test methods. However, in AutoChrom, users can add notes that contain the defined procedure or user data fields that reference the SOP or STM. The guidance states that all the steps should be described in sufficient detail for a skilled analyst to perform the analysis. So making sure that you have that detail there. In AutoChrom, the parameters that were used for the ideal method would be stored within the project, so you don't have to worry about recording that information. It's already there for you, and that can be exported into reports or it can be pushed into a database. So a little bit more on reporting. Now, aside from saying that the procedure should be documented in enough detail for a skilled analyst, there are not specifics on exactly what must be included in the report. I think this is partly because of the large variety in types of analytical methods that could be used with ICH Q14. Now, if you took an enhanced approach, it does state that the MODRs and PARs should be included along with the information on the model if you used a multivariate model. So software can be used to help with some of the reporting needs of Q14. However, some elements would be handled by the SOPs, test methods, QRM, validation documents, and other systems like I mentioned. So AutoChrom does give you the flexibility to report all elements that were captured during screening, optimization, and robustness into one document, including the instrument configuration, which can help in completing both your analytical procedure and control strategy. So this is just an example of what a report could look like. Generally, they would be more than 3 pages in length because there's a lot of detail. There are many chromatograms that are acquired along with the peak tables that can contain like the area percents and then like labeling of the best column, the best solvent, etc. In terms of documentation, you could also update your information to a database. So this is one click. There's a update to database option. This can optionally include links to documents like your analytical procedure or the ATP if you want. So you can keep everything in one place, and you can also create reports from here. So this is just an example of something that I've created. And the analytical procedure and the ATP that are shown here are snippets from ICH Q14. You could actually create these within the database that's here, and then they would be fully searchable as well. Now let's move on to the enhanced approach. So we're going to kind of cover 2 pieces at the same time. So conducting risk assessment and evaluating prior knowledge to identify the analytical procedure parameters that can impact performance of the procedure, and conducting uni or multivariate experiments and/or modeling to explore ranges and interactions between identified analytical procedure parameters. Now, the reason we're doing these together is because they both fall under risk assessment and some elements into the identification of parameters, set points, and/or ranges. So we're going to look at this first piece. So risk assessment uses your knowledge and modeling knowledge to know the limits of failure. We already actually discussed some of this in relation to points in the minimal approach. This was the Vary Method Parameters tool, which was a little bit more manual, as well as the robustness wave, which is creating an experimental design automatically. Now, in this case, let's look at the point that relates to modeling for risk assessment. So during optimization, using scouting runs, you collected the software samples the entire chromatographic design space. By creating this design space, you can simulate separations to predict the impact of adjusting method conditions without the need to perform countless experiments. You can optimize key separation parameters such as pH, temperature, gradient, solvent ratio, in order to meet the defined success criteria like runtime, retention factor, resolution, which can then be visualized on the color-coded resolution maps according to the success criteria that you set. Now, by sampling the entire design space, you can also identify areas with maximum robustness. So changes in temperature or gradient won't dramatically influence the separation quality. You can also identify the edges of failure just by looking at the resolution maps. So once the most ideal conditions are identified by chromatographic simulations, you can actually acquire the data under those suggested method conditions to verify that you have a successful method. In this case, you can see the green chromatogram is the experimental and the black is the simulated. Now they lie mostly on top of each other, which tells you that there's an excellent agreement between the model and the experimental data. Now, if the experimental data and the simulated chromatogram did differ, you could add the new experimental data to the model for additional refinement. So I think this is the last item of the enhanced approach here. So we're looking at defining an analytical procedure control strategy, including set points and/or ranges for relevant analytical procedure parameters. This could include proven acceptable ranges for analytical procedures or PARs and/or method operable design regions. Now this falls into identification of parameter set points and or ranges, as well as the control strategy. So let's break this down a little bit. So the analytical procedure control strategy contains the information gathered from developing the procedure, ensuring that the procedure is fit for intended purpose during routine use. Now, really the analytical procedure control strategy is not something that can be handled by one piece of software because, again, there are so many different types of analytical methods that produce varied results. Or even within chromatography, you could have different knowledge about one product than the other, and that would change your control strategy. Now, while there is no one software that can automatically create this, a lot of the information needed could be placed into a database like I showed earlier. You can list out any parameters that need control in created fields, store information about the best method and how it was achieved. Any other things that you wanted to add into this, you can, and it's all in one searchable place. Now, like I mentioned before, again, this is the same example that I showed, but it is fully configurable to store and visualize what you need. So the second part of this one is looking at the method operable design region. So an MODR consists of combined ranges for two or more analytical procedure parameters within which the analytical procedure is shown to be fit for intended purpose. This is the definition from ICH Q14. Now, the software will identify and label, as well as report, the MODR found in optimization from the established design space. In AutoChrom, we define a rectangular MODR with maximum size, and it contains an experimental center and non-zero suitability throughout that region. Now, the images shown here can be visualized within the software, like I mentioned, or put into reports as needed. So now we've covered everything in both the minimal and enhanced approach. Let's return back to this diagram that we've been referencing. So, like we've been saying, ICH Q14 refers to analytical procedure development. So specifically this region that's marked in orange. Now, as we saw, there are aspects of the software that can help with all of these. Now, if you extend beyond that, for the factors that feed into development, there are elements of the software which can help with all of these that have the green check mark as well. So AutoChrom is using data to make decisions in method development, and it can help you apply ICH Q14 guidelines to your chromatography method development to generate reliable methods in a more efficient manner. Now, if you want to learn more about AutoChrom, you can check out our website where you'll be able to find specifics on the AutoChrom product page. There's a blog that's about ICH Q14. And also other documents and webinars from customers that are already using the software for their method development. And if you still have questions, you're welcome to reach out to us. At this point, I'd like to thank you for your time, and we'll start our Q&A period. Okay. So I see a question here. I understand that your software uses both science-based tools and statistical-based tools. Is this sufficient to address Q14, or do we need other stats packages? So you're correct. There are both science-based and statistical tools in the software. The guidelines state that you can evaluate sources of variability using statistical tools, ensuring that you have a good model, but it does not state specifics. So like I mentioned, we do interface with JMP, and we do use it as a default in the robustness wave because it's thought to be the best of the available options that are in AutoChrom. Okay, another question here. Does the Q14 document give any specific reporting format? Is there a format that ACDLabs suggests or provides? So given that the document applies to so many different types of analytical methods, there's not a specific format that the guidelines outline. They do suggest certain things to include, especially if you're looking at the enhanced approach, so including the MODRs and the PARs. And we don't have a specific ICH Q14 format. You can create templates in AutoChrom so that you have your own format. But like we said, depending on the knowledge that you have leading into this, you might want different pieces of information displayed. So we also offer something called a standard report template. And that's, I think I had a screenshot of that, but it's very user friendly. So you can just select which pieces you actually want to have displayed in your report, and it'll generate the report for you. So you don't have to build the templates yourself. So you've got flexibility both ways. How reliable, how reliable are the software recommendations? Does it alert the user if there is something that they shouldn't be doing? So this is a great question. In general, I would say the models are as good as the data that you put into them. My PhD supervisor always said garbage in, garbage out. So if you put good quality data in, then you should be getting a reasonable fit. I believe there was a publication by LCGC in, I think it was 2018, and they were looking at small molecules, and I think they had, it was like less than 0.1% for retention time prediction. So it was pretty accurate for them. Oh, sorry, the second part of that question was alerting the user, right? So there are warnings in AutoChrom if you're doing something that you shouldn't be doing. The software will say, basically, you shouldn't be doing this, and do you want to proceed ignoring this recommendation, or do you want to fix this issue? And I'll kind of give some guidance on how to do that. Okay, and I think we have time for one last question. How do users learn AutoChrom? Okay, so AutoChrom is considered an advanced tool. It's for expert users. There are training sessions that are part of the package that you purchase. So you would work with one of our application scientists. Generally what we do is you send a little bit of data our way, just maybe of some standards, and we would create an example training project for you. And then the application scientist would go through that with you. So we get the data up front just so that we can start it, and then we work through the rest of it with you live. If you're using an online mode that's interacting with your CDS, then partway through the training, you'll be acquiring data, and then you'll process it together with the application scientist. In addition to this, we have very detailed training manuals. There are, I think, a quick start guide and a video that can also help. And then I guess the last piece is support. So one of the things that we're known for is our excellent support system. We have people all around the world, so you get a response fairly quickly, and there's ways to access support from within the software or from our website. Okay, I think that's probably all we have time for today. Once again, thank you very much for attending this webinar. And if you have further questions, or if we didn't get to your question, then we'll be reaching out. Thanks again.